And good morning, everybody. David Cross here. I thought I'd throw in a video real quick on response policy zones and the setup within IPControl that gives you the ability to set up either blacklist zones and or whitelist zones so that if you have anyone inside your organization that might be compromised or a machine that might have some type of malware, etc., that you can use DNS to block those devices and or slow them down if they're providing denial of service attacks and things like that. So what this is going to introduce, or this video, is an internal RPZ or response policy zone setup. And then we'll show you how that works and effectively how you might be able to even set these up dynamically to allow you instantaneous blacklisting of devices or whitelisting. And also, this setup works the same way with our DNS firewall through BT, that you can have an instant feed that is kind of an aggregate of the different blacklist in the markets, and we aggregate those and feed them down to our customers. So there's a number of setup, and I'm going to go through each of those, deploy these out to one of the DNS servers we've deployed, and then kind of show you some queries and how the interaction works. So to begin with, RPZ zones or domains are just like any other domain. And what we want to do is effectively create two new ones, basically a whitelist and a blacklist. So I like to use mine in a term that makes sense, and I use .int to represent internal. And the key to these zones is that you want to select the local RPZ starting with IPControl 11. So what we're presenting today is showing you the new interface for adding resource records within IPControl 11, the latest version. So once we've created the RPZ list, you can also associate any type of user-definable records if you want to keep track of that type of information, and so forth. So we're going to go ahead and use this as default and create the whitelist, and then we're going to do the same thing with the blacklist. And we'll call this one int as well, and we'll make sure that we select the local RPZ, and this checkbox actually enables the resource record capability to manage those. All right, second step, once we have the RPZ zones defined, we need to delegate those to whichever servers. Typically, this would be done at your recursive server, like your tier 2, what we refer to them, or your secondaries, where if you're internally trying to blacklist these or block devices, you would do it where the recursion occurs or where your resolver happens. So we want to go into our DNS server, and we want to select the options tab, and I have a few already set. So we're going to show all options, and we're going to navigate to the response policy. A little bit further down the list. Here's a response policy, and there's two options here. We want to select the top group details, and here we want to specify and we want to do the whitelist first in the list, and this will be given. And the different policies you have, you can either say for anything in this zone, go ahead and deny it, so basically disabled, or set up index domain or no data. You can also drop that information or pass it through, or supply given, which allows you at the resource record level the capability of dictating whether it's blocked or redirected or passed through. So I'm going to use given since we're going to do this within the policy, and that's effectively all I need to do there. We'll go ahead and add our second RPZ, and we'll do blacklist.int, and again we'll do given on this list. Now we want to make sure of the order so that if we have a device that is currently in the blacklist, we can add it to the whitelist if we decide that it was falsely identified. And vice versa, if it's in the whitelist, we can move it to the blacklist. And then anything in the whitelist, since RPZ triggers are effectively the first trigger that matches, is what is resolved back to the client, or however the trigger is processed. So that's it. We just want to go ahead and save those two settings there. And the third step is we need to delegate these zones to our DNS server. So I'm going to go ahead and select master, which is what they will be. And I'm going to go ahead and add those. So we'll do blacklist as a matter of the order here. And I do want to actually do this in a dynamic way because I want to be able to control my records. So I'm going to allow for the DNS admin's address match list to update this list dynamically. And I'll show that list because it has a TSIG key in it that allows this. And in the zone options, we really don't want anybody to be able to query, but I am going to specify that DNS admins can query this, and that I do want to have the DNS admins also to transfer so we can do testing. And we do want to do an also notify so that if we dynamically update the DNS, it notifies our executive on port 5053. So this way we can keep those records in a two-way sync between the DNS and for the IPControl database. And we'll go ahead and select these. Those should be the only options we need. And we'll go ahead and submit that. And we'll do the same thing with the whitelist zone. And our update will be DNS admins. And allow query, we're going to do DNS admins. And allow transfer the same. Also notify 325053. Okay, and now that we have these zones configured, we can go ahead and deploy the configuration. And since this is a master server, you'll need to deploy effectively all of the zones, so all files, so that it can build the configuration. If you're, pardon me, running dynamic zones in this configuration, meaning that any of the zones that are on this server, if they're currently dynamic, if we go and deploy all zones, all files, it'll overwrite those dynamic entries. Make sure that you freeze a zone, run the command line to do those changes to make sure that that occurs. Okay, or let's go ahead and do change zones only. And let's see if we can get this to commit to it. Okay, and then by looking at that, it looks like we can use the change zones only. So we should be able to deploy that. And that will only then write out the RPC blacklist, the whitelist, and the name deconf and reload those. So we'll go ahead and do that. It shouldn't override our server, which would be good. And we'll wait for that to finish up here. And you can see that it's transferring, and that should be complete then. Okay, and before we jump into that, let me kind of back up a little bit. I jumped ahead of myself here. So in the management DNS under address match lists, you saw that I selected DNS admins. I have a DNS admin key, which is the name of one of my TSIG keys, and remember, it has a trailing dot, that is allowed to do updates, as part of this particular group. And I also have .32, which is the executive, and I have my other executive .55 in this list, since I'll be exchanging between this appliance. So that particular list then has access permissions to dynamically update. So if we go back and look at the zones themselves, and in the primary, when we look at the update, they're able to update their records, or these records, and it's also able to query. And the key to this is, if you're doing dynamic updates, RPZ zones, again, are not intended to be queried by resolvers or external clients. It's intended to be internally queried by the server and processed as a trigger to determine its outcome. So we don't really need to query this ability with the clients. However, if you're doing dynamic updates, you have to be able to query the record in order to add, delete, to ensure the prerequisites. So I just want to make sure you understood that. And again, if you made any changes or if you had to add that back, go ahead to your DNS configuration, and we're just going to go ahead and select the name server again and do change zones only. And this should then perform the checks, do the DNS zone check, and stop if any critical errors. And we're going to go ahead and run that again, just so we make sure it's updated in case you had to make any changes. Now, behind the scenes of this, and once this happens, I'm going to set up one of my utilities to allow me to query and dynamically update the zones so that we can see kind of in real time these IP addresses being blocked and or host names being blocked, since we can modify both. So let's give this a push, make sure we get a success. And there we go. So if I go out to my machine now, I don't have any SOA for this, but if I do a transfer, I can query the device. So this IP address does have the TSIG, so it does have a DNS admin key that we're then using for this key value for doing the transfers and updates. So when I do a zone transfer, there's no records there. But if I were to go in through my client and add this IP address you'll see that it creates a record, client IP, RPZ, blacklist, and it appends some data to it to instruct it what type of trigger it needs to apply. And then if I go back and try to query those devices again, and I have a device on there, my time server Pi, you'll see that I get an NX domain. So the trailing dot to the record tells it NX domain. The dot asterisk dot is no data. So if you're doing like denial of service attacks, you can just drop the packet or do no data in there. And the other is pass through to allow the query through. If this should be like whitelisted, drop it and or force it to TCP only. Okay, only when it's on a TCP. And then we can delete this as well. And as you'll see in real time, we can then go back in and start querying the device. So very, very cool the way that that works. And you can actually have this propagate down to all of your slave servers. So organizationally, you can have this globally defined so that these dynamic updates are propagated immediately to secure your DNS. And in IPControl 11, we've added the ability to do all of this simply within the zone records. And in those resource records now, when you select this, you'll have an RPZ policy or the standard. The RPZ policies are always CNAME records. So we've highlighted this and grayed that out. But there's different triggers that you can use. One of these being the QNAME, so we can have it set up that it's a resource record name, like www or something. We can do wildcard matches as well. We can do subnet addresses. So if you were to specify something here, I could say deny my entire subnet and give it a 24. Maybe a short TTL, that it goes out and looks at. And then the policy is to either drop it with an NX domain or respond NX domain, respond no data, drop the packet, TCP only, which allows for, again, forcing TCP, and pass through and local are different policies to allow it through and or a different policy. So if we were to save that, IPControl is smart enough to reformat this IP record or DNS record to match the format for the RPZ IP. So RPZ-IP is the trigger for a subnet. And if we look at this from a client perspective, and we wanted to say block an IP address, I could do this from an IP. And it will automatically, when it does that, preference it with a /32 size. So this first one would be the first trigger, and it would actually block everything in the subnet, so this would never be reached if it were in that order. So I could just go ahead and delete this one here. But if I were adding this through the interface, I would then save the record, and I could then go back to the configuration deployment and select to dynamically update the records for those zones. And this will then propagate those records again out dynamically. And kind of the intent with this is that you might want to set up a schedule that runs every minute, every couple of minutes, checking for dynamic records within a time frame that is controllable, that these can be updated without having to impact the remaining services. And then if I go out and do the zone transfer again, you'll see that we have the record here. And this should then again start blocking that address. And we'll get an NX domain there again. Now, other things you can do with this is like redirect your clients or rewrite the query or the answer to something else. So if someone were to query a device that was blacklisted, you could then redirect or rewrite the answer to redirect them to a website or resolve it to a website. And if they launch a browser, it might tell them why they were blacklisted or what the device was or what the query was. So there's a few things that you can do there, and this is just one key thing that we have provided to help you manage the DNS and provide some quick DNS security where it's needed. And then at a later time, as we get into some of the DNS firewalls, I'll kind of go over some of that setup and explain how that works as well. So hope this works, and feel free to test it out in the lab. Just make sure you don't push your DNS primary if it's dynamic. Make sure you take those controls necessary. And try it out. See what you think. All right, take care, everybody, and we'll come back with another video in a future time. Thanks.